All right, so I'm live with Assimilate Python from zero. Every week I go through and add more lessons. And this week I'm going to get into lists themselves and just only focus on lists. So let's go ahead and share my screen here and get started. And here we go. We got lists here, and we can dive into this. And in particular, I think it would be interesting to build some stuff in Colab. I think is probably the place to go. So let's start with that, and we can go back and forth to other environments too. But I'll create a new notebook here, and we'll call this Python lists. Lists. Okay, so I've got Python lists here, and we'll say getting started. Or this first step, I would say just making one. Right? So we would go through here and we would say my list, and inside of here we could put really anything, right? You can do 1, 2, 3, 4 stuff inside. Now, what can I do with the list? I think the best way to think about a list is that it's like a bag, right? Where you just put things inside, and we can first look at it. Like if you just want to type a list, that's a good way to see what it is. And if I'll grab the first thing out of it, I can just say my list here, and say 0, and that grabs the first item out of the list, which is 1. If I want to grab the last one out of it, I can also do my list, and I can just do a -1. I can just do -1, -1, like that, and it'll give me the last one. Now, you also can take ranges as well, so you can slice a little bit off the front, you can take a little bit off the back, and this is kind of a fun way to do things. So you can say, for example, my list, and if I say :1, so basically the first item from the list. But if I said :2, give me a couple things from the list. It'd give me 3 things from the list. If I did 5, it should blow up. I guess actually just interesting behavior. So I guess if you don't have more than what's in the list, it just won't return anything. So that's kind of a fun little behavior I wasn't aware of. If I do the other way though, if I just say this, it shows everything but the first one, everything but the first 2. So probably the main takeaway with a Python list is play around with these different syntaxes. This is how to get the first thing. Here's how to get the last thing. And I could even put a note here, like get first, right? Add another note below, get last here. And then, right here we could say get all but first 2. Right? So kind of a fun way to play around with this. Now, if we want to make something a little bit trickier and do more stuff with it, I think one of the things that comes up a lot is, and we'll just maybe call this using lists. Using lists is that a lot of times you want to actually find out how many things are inside. And so let's just call this LL. This we just had inside of this list a few different kinds of things, like an apple, a pear, and like a banana or something like that. Do that. What I can do is I can say len LL, like that. And so, oh, look, there's 3 things inside the list. So this is sometimes the first step for you to actually do some kind of programmatic operation, is just figure out how many things are inside of the list and play around with it that way. Now, the other thing about using a list is a lot of times, other than just slicing, you may want to actually do a loop. And so if we want to loop through this, we would say for fruits in LL, right? And then you would go through here and you would print out what's inside of this list. You'd say print and say fruit, right? And you just get replaced the variable, back and forth, every single iteration of the loop. And that actually is probably the most classic way that you would do something. Now, Python does have this thing called time it. And so if we went through here, let's actually do this. Let's try something kind of fun. Let's make like a large list. And so for example, we could populate a list full of items. So if we said collection numbers is equal to this, and then inside we can say for I, so for I in range, we'll say 1 to 50,000. Let's do 5,000. That'd be better. 5,000. Let's put them inside of this list. Numbers dot append I, right? So I want to just make a big old list, and if I say len numbers, it should be 5,000, right? Or in this case 4,999, because of the fact that it stopped, right? So we could even do 1 to 5,000. Let's try that. There you go, 5,000. And if we want to look at the end, right, we can also do numbers and do minus. That should do it 5,000. If we look at the beginning, we would say numbers. And we can say 0, because it's index 0. So we've got 1 to 5,000. And what would be kind of interesting here would be that if I wanted to loop through and I don't know, like, what could I do that would be kind of fun? Maybe manipulate it somehow. So if I said for num in numbers about we like a string or something, and so we just would say like we could do a template, we could do f string, and we could say like my number or something like this, and then put it in, and we won't even print it out because we don't care my number, right? I just want to time this. If I say time it, I'd like to see how long it takes for us to go through a list and actually get results. And let me just double check Colab notebook timer. Is it time it or timer? Timing and profiling. Let's see here. So, time it. I see. So we need to put this under time it like that. Okay, so we need to put it up here. So we need to do this, time it. If we run that, it's going to go ahead and just profile this code for us. And so we can see that this is 9.23. I think this is microseconds per loop. So let's make it even bigger so that let's do like 50,000, or let's do 500,000. Big loop. There we go. There we go. There we go. Now let's make it be a little bit slower so we don't have to get into like um, very obscure things. But I guess let's make it even bigger. Let's try that. Let's try that. I just want it to be like a number that's easy to milliseconds. There we go. Milliseconds. I like milliseconds. So it's 15 milliseconds to go through what is this like 5 million loops. Now can we beat that if we do um, another kind of, there's 1,000 milliseconds in a second, right? Can we actually beat that by actually using a different kind of looping mechanism? And so Python has something called list comprehension. And if we go ahead and we type in list comprehension Python, go to the official documentation here, and we look at a list comprehension. Notice that what it is it's essentially a backwards loop, right? Like this, it's the equivalent. And so we can actually just copy this and do the same thing. And so if we go back here, we could do this. We could just say like, like format or something like this. And we could do this part of the loop. So we would say this for num and numbers. And then we would just put in this statement right here. And now we can use the same thing. We can see which one's faster. Now, that was way slower because maybe we don't need to assign it to a variable. Let's try that and see if this is the trick here. I guess the idea here is to try different time operations to see if the list comprehension is much quicker, because the list comprehension in Python in theory should be quicker, but it could be that in this particular situation, because this is a weird calculation, that maybe it doesn't make sense. Now, what we could do is we could do something trickier, which we could say counter is equal to 2. And then we could basically say counter, and we go to, maybe we just multiply by the number. If I go exponential, I think this is not going to end well. Let's try this. How long does that take? So that's actually pretty interesting. It took 11 milliseconds. Now, if we do the same thing here, what happens if we change that and we look at it? Counter. Oh, we need to put that like other counter. Or no, I guess we can do the same thing. We'll just override it. So that is faster, like in this case. Now, we could also change this up and maybe make this only do like 500 here. Right? And then 500, right? This. And now we can change this to an exponential function like that. And that should make things a little bit slower eventually. And so, and this is where we've got I don't do profiling that much, so I have to look up these characters. So there's a microsecond, and then I got to look up what this one is, and this is okay. So that's a total of 241 microseconds. So this was faster. There we go. So we looked at it. Is that basically because this is exponentially, getting larger and larger and larger and larger. In fact, we could even show you what the number is. Maybe a big number at the very end. We could say Prince counter. That. Oof. What's weird is why is it printing this out? It shouldn't be printing this out until the loop's over. So that's kind of annoying. Let's clean up this cell. Let's go clear output. There you go. So that's strange. Oh, I see. Because we want to say counter. We have a bug in our code. we have a counter equals counter is equal to counter to the exponential. And we should only print once. We don't need to do it. But I guess what we could do is we could just take it out of there. Counter equals counter there, and then we could add another cell below. So we do that. First, let it do its magic. Now this is going to take a while because it actually is using a bigger and bigger counter value, and it may be too much. This thing may turn into a crazy benchmarking function here. So yeah, taking too long. This other one was actually better for a few different reasons, even though it's kind of a silly thing to do. And we can see at the very end that that's funny. It says counter not. I guess it doesn't save state between the two different things because it's using this timing operation. But in a nutshell, we can see that for a very tight loop, a list comprehension can be something that improves things because of the fact that it in between the runs is using like lower level C programming to do these tight loops. So I guess that's maybe a section we'll add here. I'll just say, should you use comprehensions? No, comprehensions. Yeah, the other thing that's kind of fun about lists here is that maybe we can throw these up and hide these things here, is that you also can kind of combine them in more of like a functional programming way. And so in this particular scenario here, what are some of the things that you can do with a list, right? You can create like a nested list comprehension, right? So you can create a matrix, for example, and then you could do some kind of matrix operation. So let's try that. Let's go ahead and build a matrix first here. So we'll say matrix equals, and we'll do this. So a matrix is just a list of lists. Just let us, no, it doesn't let us, there you go. And then inside of the matrix, let's put these numbers like that. There we go. Next line, we'll go like this. And then next line, go like this. There we go. So we got a matrix. Type in matrix. You can see the matrix, right? It's a list of lists, multiple lists inside of a list. And then if you want to use a super fancy list comprehension, you could do that. And you could go ahead and run that. This is obviously the official Python docs. So it is kind of a cool concept, and you can transpose as well. And I forget where that is from, if we say Python transpose matrix transpose, I think it's built into the language. Zip. There we go. So you just do that. You just do zip matrix. And it should just flip it around. Right? Because this was the original matrix, and this is the new matrix. And you can see it swaps the direction of things. And so that's one of the fun things about a list is you can do these kind of exciting, things by using list comprehensions and playing around with them. So that's really, I would say some of the fun things you can do with a list, and loops, assigning things to it. Maybe one other final thing that I could show that's kind of a fun thing you can do with list is choices. I use this a lot. So we'll say random choices. And we always need randomness. So we'll say from random, there's a random library, import choices like that. And then if we look at choices, we can look at the documentation for it. And it says takes a population, weights, cumulative weights, returns a k-list size list of population elements, right? So we would want to put it into there. So we could go through here and we could build out a like meals. Let's go to meal planner, and we would just say like salad, steak, fruits, and I don't know, yogurt. There you go. These are meals. And we can just say choices, meals. And every time I run this, it will give me new results. And it's completely non-deterministic. Right? It's just going to randomly pick something. So you could do something like this with a list as well. As you could say for I, or even throw that away. Basically just grab 10 results and you just say choices. And you could do a print statement that says print meal number 1, meal number I. So we do need this loop variable like that. So meal number I, and then we would do this. Choices. We can even pop that off. There you go. Meal 0, yogurt, steak, yogurt, fruit, salad, right? So there's some really cool things that you can do with lists. All right, so I'm going to take this lesson here and I'm going to save this into GitHub, into my Assimilate Python notebook repository. This should be pretty easy to do. Notice again, Colab Notebook can go ahead and save these things very easily. Assimilate Python from 0. Perfect. All right, well, that is it for today. Next week, we'll continue to cover more exciting things on Python. All right, see you then.